So first off, I'd like to say a very big thank you to the organizers, both for having this meeting and for inviting me here, but also for everybody who's been involved in NASSP over the many years, because I think for many of us here, it has played an instrumental part in our various different careers that we've had. So very briefly, how I got to here, through NASSP, obviously, but I started here in Cape Town with my BSc in physics. Astrophysics didn't technically exist, I think, as an undergraduate major when I started, but it did when I finished. And then I came to UCT in particular because it was starting to be the hub of NASSP, and NASSP had just come into being, and I wanted to pursue astronomy, so it seemed like a good place. So I ended up doing my honors through the NASSP program in 2008, and then did my master's still here in Cape Town, but just master's by research. And then I went to the Netherlands for my PhD, and I did a couple of postdocs hopping back and forth between the Netherlands and the UK, and I've landed up now at the Square Kilometre Array headquarters in the UK, based at Jodrell Bank. A little bit more details of my research history through the science that I've done. NASSP Honors really introduced me to research for the first time, and I think really was instrumental in building a wider network of exposure to international research in astronomy. So I did my research, a lot of time spent up in Sutherland at the IRSF telescope, peering for these distant galaxies, hidden behind the Milky Way, behind all these stars and all this dust. And then learning a lot about how to actually do science, how to reduce data, getting rid of the nasty stars and doing accurate photometry of these galaxies. Sort of interlude between my honors year and NASSP Masters, along with Cosma van Maltitz, we coordinated the NASSP Summer School. So the summer school was itself to participate in at the beginning of the honors year was really a great experience and a good start to the year. But it was also a very useful experience for myself to coordinate the summer school and introduce the next year of incoming honors students to the program. So some of you recognize yourselves touring the SAO library, the old telescope at the SAO. Exciting times building rockets. And one of the more fun things, the introduction to program. For some people, their first time doing programming by programming these Lego robots. I then went on to do my master's here in Cape Town with René Kraan-Korteweg, and starting to get a little bit more into the field of radio astronomy, because this was a very exciting time for South Africa. SALT was being built, but it was still being decided where the SKA would actually be, and South Africa had a bid in to host the SKA. So radio astronomy seemed very promising. I got to go to the Parkes telescope in Australia and do some H1 spectral line observations. And the focus of the research was to try and understand the distribution of matter, particularly in this obscured part of the galaxy, but behind this obscured part of the galaxy, it's very difficult to observe where the galaxies are. So using things like the Tully-Fisher relation, combining these near-infrared observations I spent doing during my honors here with new H1 observations. One of the exciting things, I got to go to the 10 years celebration of the IRSF telescope, and this was really cool with the NASSP alumni from my own year, Zara and Salahari. We got to go to Japan for one of my first international conferences. I then went on to do my PhD in the Netherlands, and I think there were a couple of reasons NASSP was quite useful in doing this. Both the excellent NASSP Colloquia series, being exposed to a wide range of scientific research from international astronomers as well as South African astronomers. There was one colloquium I remember on active galactic nuclei, which sounded quite cool. So the topic of a proposed PhD project in Leiden was on active galactic nuclei, so I was like, oh, this sounds quite cool. But also the network of South African researchers we were exposed to during NASSP actually was instrumental in making one of those connections with the professor in the Netherlands who was offering a PhD project. And again, the future of radio astronomy seemed very bright in South Africa. So it was a year after I started in the Netherlands that the decision was made to host the Square Kilometre Array in South Africa and also Australia. So a lot of my research, even now still at the SKA, is focused on low frequency radio astronomy, and this is the instrument I've used, the low frequency array. It's based in the Netherlands, but spread out through Europe. And like the SKA, it's kind of two telescopes masquerading as one. It's made up of, on the left, you have the high band antennas operate at 150 megahertz, so these are FM radio bands. And on the right-hand side, the low band, you can see are about this big. They operate at sort of 10 to 70 megahertz at very, very low frequencies, so wavelengths of 4 to 8 meters. When I started in 2011, this was a newly constructed telescope. I think they were actually still finishing a couple of the remote stations building, finishing some of the international stations being built. And to be honest, we had no idea how to process the data. It took me 4 years of my PhD to make some of the first images. Just to mention, the telescope itself actually has stations from Ireland across to Latvia, from Sweden in the north down to France, Germany in the future, Italy in the south. So even in the SKA era, this is going to be a unique telescope probing extremely high resolution, so sub-arc second imaging at these very low radio frequencies will remain unique even in the future. One of the biggest challenges is how to deal with the ionosphere. So this layer of charged particles which changes the light propagation of the radio waves through the atmosphere. And you can see on the left-hand side, sources move around like crazy over timescales of a few seconds even. So this is actually like doing adaptive optics, but implemented in the radio and doing it after the observations. So as I said, it took, I'll skip over that. It took me my whole PhD over 4 years to figure out how to actually make these images. So this was the very first wide field deep image made with LOFAR. It looks like a blue blob. These pictures are terrible to show on screens, but if you zoom in, there's thousands of individual sources, individual star-forming galaxies and the jets coming from the supermassive black holes at the centers of galaxies, these active galactic nuclei. I've done a lot of science using this data at the end of my PhD, looking at the various populations of these active galactic nuclei, what sort of galaxies they live in, and how this evolves with cosmic time. This was just the first image of one part of the sky. I'm part of the LOFAR Surveys collaboration, where we're imaging the entire northern sky, covering, you can see in the little bottom right, the entire northern sky. We're very big international collaboration, but we're using all the different features of the telescope. So I'll come back to that. We're using the low band, doing very low frequencies, so the 60 megahertz, but also going to the very lowest frequencies that you can probe on the Earth, going down to 15 megahertz and actually making images of the sky. And then also using the international stations to go from what was a really nice image to us at 5 arc-second resolution. These images were quite amazing. To go even better to arc-second resolution. You can see that on the top right. Yeah, sorry, I'm backwards, left-hand side for you. And then also going very, very deep, using hundreds of hours observations to get the very faintest sources, star-forming galaxies, but also to get the most distant things, to look at the evolution of galaxies over time. One of the things I've also been very interested is combining the radio with the optical, so we can get all the information, stellar masses, redshifts, all the information from the optical sources. So a big part of my postdoc work has been to produce the value-added catalogs for the lot surveys. And we've also used citizen science, so there's a LOFAR Galaxy Zoo project. There's other ones ongoing right now of how to actually connect the radio components together into one source and to identify which is the optical source that matches to them. And really this work has enabled a wide range of science to be done, again looking at these active galactic nuclei, looking at the radio morphologies, that's on the left there, looking at their sizes, their radio powers and their evolution with time through different tracks of that size luminosity size plot, and looking at general population statistics of these sources. One of the really exciting things I got to be a part of during my postdoc years, both in the Netherlands and in the UK, was through this DARA project, the Development in Africa with Radio Astronomy. It was originally funded through a UK Newton Fund project, but also with contributions from the Netherlands, which is why I got to participate while I was in the Netherlands. And this is a program that aimed to teach radio astronomy to a wider range of African students. So it had a wide range of radio astronomy courses, including a practical data reduction course, which I've taught twice, both times along with fellow NASSP alumni, in 2017 with Roger Dean in Botswana, and in 2018 with Zara Randria Manakoto in her home country of Madagascar. So since last year, I've been a project scientist now at the Square Kilometre Array headquarters in the UK. It's really nice to have landed up at SKA since I started my career thinking this might be a thing that might one day exist, and it might be interesting to follow this. So my role there is to continue to do science, continue to work on these LOFAR surveys, and future surveys both with Meerkat and SKA and SKA Low in Australia in the future. An important part of my role is also engaging with the community, being an interface between the scientists and the engineers who are building the telescope, and to make sure that the telescope achieves the science that we want it to achieve. Where certain decisions are made for funding reasons or construction reasons, that we want to ensure that the telescope can still achieve the science that it was envisioned to do. So just a quick reminder to those who maybe don't know, the SKA consists of two telescopes. The low side, it will consist of two telescopes, low in Australia and SKA mid here in South Africa, that will eventually incorporate the Meerkat dishes. So low operates at below 350 megahertz and mid above 350 megahertz. And both of them will be sort of an order of magnitude improvement in sensitivity and resolution at various frequencies. So the SKA organization, South Africa is one of the founding members. There's a number of other members that are still in the process of formalizing their final agreement, but since 2021 it has been an intergovernmental organization, the second only to ESO in astronomy. Last year was very exciting. We celebrated the commencement of construction, so the last year has been very exciting. Well, in some ways not so exciting to see some of the images of the construction because they've just been digging trenches, laying cables, and so on. But last year we celebrated the beginning of this. Yeah, so the past year has involved a lot of activities of building stuff, digging holes, laying foundations. So this is some pictures from mid and low in Australia. I've heard that the very first SKA dishes to arrive in South Africa should hopefully make landing from the ship to land tonight, maybe. So it's a very exciting time to be involved. Very briefly, SKA will cover a broad range of science topics. I'm not going to go into all of them in detail. Everything from general relativity, testing fundamental physics models, looking at the dawn of the first stars in the universe, the evolution of the universe, growth of galaxies over time, looking for the signs of life around new planets, looking for planet formation, and a whole lot of new unknown things as well. Just towards the end here, I just want to mention that the SKA science community, and this is my work involved in engagement with the science community, mostly happens through our science working groups, consisting of over 1,000 scientists across the world in 14 science working groups. We have 50 members of the working groups in South African institutes, and we'd really like to see more, and I think programs like NASSP really help to build the South African community in this regard. And the science working groups are really the way for the community to engage with the SKA, to become involved in working with the data and understanding what science it will do. So just a quick advertisement as well. If you're not already involved and you're a published scientific researcher, do join, do get involved. And just to highlight once again, I've come across NASSP alumni at various occasions, various large international meetings. But just last year, I was at a Spanish SKA collaboration meeting, and there were 3 of us there who were NASSP alumni, myself, Amadou, and Roger, also from my year of NASSP honors. So it was really great to see NASSP alumni out there doing SKA-relevant research. So yes, it's a really exciting time for SKA. It's an exciting time to be a South African researcher working on the SKA. The construction has begun, and in the next coming years, we'll start to see early data, early commissioning being done. And we hope to see many more South African and African researchers participating and using the data from the SKA. So I will say thank you there. Thank you.